Okay, so for the average atomic mass, this is our last topic for the unit, but average atomic mass is the weighted average of all naturally occurring isotopes of an element. This is the number that's on the periodic table. So here's our equation here. Basically what you do is you take the mass of an isotope, so maybe isotope 1 here, and the percent of the atoms that are that isotope. You multiply those together, add the mass of the second isotope plus the percentage of the time that that isotope exists, and divide by 100. Now this can be done multiple or more times. So if there are 4 isotopes, you would do each section, you do that 4 times rather than just twice as what's shown here. But this is our basic equation. And now the average atomic mass is what's shown on the periodic table. So the scientists took each isotope of each element, figured out its percent abundance, and calculated the average mass that way. So here's an example of what a problem would look like. So this says calculate the average atomic mass of oxygen if the abundance of different isotopes in nature are the following. So we have 3 isotopes. The first isotope is oxygen 18. Now remember, when we write out elements like this, that is the mass. Okay, so we have, so the first one has a mass of 18 atomic mass units. It exists 0.04% of the time. The next isotope has a mass of 16 atomic mass units and exists 99.76% of the time. And then the last isotope has its mass and its percent abundance. Now let's look at how we plug this in. So when I plug this in, I take the mass of the first isotope and the percentage, multiply those together, then I take the mass of the second isotope, multiply it by its percentage, and then lastly I do the third isotope, multiply it by its percentage, and then divide everything by 100. Now one thing that I do suggest doing is do the whole top part first, hit enters in your calculator, and then divide by 100, just to save yourself headaches. When we do that, we should get an answer right here of 15.9988 atomic mass units. Now, always double check your answer. If you get an answer that's like 3,048 or something, you did it wrong. How do I know that? Well, I'm averaging 18, 16, and 15. So an answer of 3,000 does not make sense. How can that be the average of something when it's not even close to what the numbers actually are? So just always pay attention. In this case here, almost all of the oxygen atoms weigh 16 atomic mass units, so we expect the answer to be very close to 16. And then of the leftovers, more of them are below 16, a tiny bit are above, and so we end up with 15.9988, which does make sense. We say, okay, it's right next to 16, slightly below.